السلام عليكم all. We are going to start in 5 minutes sharp. So, yeah, just I want to confirm that you are hearing me. So either you unmute yourself to tell me this, or you send me a message on the chat, please. Perfect. Thank you, Karim. Thank you. Perfect. So is my screen clear for you guys? Just unmute yourself. Okay. Let's wait 2 more minutes, then we are going to start, right? Okay, so let's start. I hope that you guys are all having a good day, a good Labor Day, and I hope that you enjoyed it. So today's session is about drilling. So we are going to talk more deeply about drilling. And yeah, I will review this too and admit them for the chat. Okay. So let's start. Oops. First of all, I would like to introduce myself. So my name is Nina Shlah. I am a drill engineer by major, and this is what I studied in the Faculty of Oil and Chemistry in Algeria, and I graduated in 2022. And during my university days, I had a lot of fun. I had a lot of extracurricular activities, which are mainly the creation of a scientific club, which name is Professional Drawing Club. So yeah, I was one of the founders of this club, and now it is turned recently to an EIDC student chapter. It's the first in North Africa here in Algeria, and it's something that I am truly proud of. I have been also a member of what we call Algerian Women in Science, which is an online community mainly here to promote and help Algerian females in all the STEM fields, including mine, so petroleum engineering. So I had the opportunity to lead the community of petroleum engineers here. And I had also the chance to be an SPE member. So I started my student um, life, extracurricular life by being an SPE student chapter member. Then I had the chance also to be a professional member. So after this, right after my graduation, so I graduated in 2022, and I found a job. I started my career within Cameron, which is a Schlumberger company. So I have been a valves and process system field engineer for almost 3 months. Then I jumped to SLB, Aix-Schlumberger, and I am a hydraulic fracture field engineer. And starting from January 2024, I took a career break for some reasons. And for now, I am enjoying my break. Yeah, and I'm trying to spread the impact around. Yeah. So let's discover together today's summary. So the summary of today will be first an introduction. So we are going to see an introduction about drilling and an overview of drilling. Then we are going to jump to discover together drilling operations, then drilling engineering, and then we are going to end up with drilling technologies. Yeah. So now I want to ask you a question, and please raise your hand. Raise your hand. So what do you know about drilling industry? I need to check who is raising his hand. You can also write down in the chat. It's okay. So I need to see your level and your understanding of this field. So please answer my question on the chat, or just raise your hand so I can unmute you and you can talk. Exploration, yeah. Yeah, Drin is here to explore oil and gas, of course. What else? What else? Can anyone answer? It's mainly for you guys, so I can understand your level in this field, so I can like be more clear in my explanations. To explore and produce oil and gas, yes. Injecting where what exactly? Explain. What are we injecting during operations? No, we are not injecting water. No, we are not using water. Water and gas injection. During drilling? No, we do not do this. Actually, we are going to discover together what we are going, what we actually uh, inject during drilling. We are going to see. Maximize the recovery of oil and gas. I think that this is part of production, the production part, not drilling. Drilling is here mainly to make holes and to reach the reservoir. Yeah, during drilling, yeah. Yeah, so we are injecting mud. We are pumping down mud. Well construction, exactly. Yeah. So yeah, this is actually I saw some words related to drilling. So as you see here, there is what we call well life cycle. So in order to understand all the story of oil and gas, we need to understand this life cycle. So it all begins with what we call exploration. So during exploration, there is what we call GNG, geology and geophysicist. And these engineers majoring or specializing in geology and geophysics are actually having their activity in this part of the well life cycle. So what they do is mainly making assumption if we have oil or gas. So we have what we call seismic data acquisition. So Oh, sorry. So we have what we call seismic data acquisition, and the geophysicist guys are there to make what we call percussions. So they how can I say it? Like they beat the ears, uh, like this, and they are getting what we call seismic data. And based on this seismic data, there is what we call a whole interpretation is in geophysics, but it's not the topic of today, and it's not my major though. So they are processing the data we are getting from the seismic activity, and we are interpreting it. Once we are done with this, we are going to tell the drill engineer if yes, there is a probability to find oil or gas down underground. Okay, so we will after this we will begin with what we call oops, sorry, with what we call exploratory drilling. So mainly, this is the first operation to confirm if there is oil or gas underground. So exploratory drilling is quite difficult because we do not know the nature of the rocks we are dealing with. We do not know what's underground. So mainly exploratory drilling is here for this purpose, in order to explore what is underground. After this, there is what we call appraisal. And actually, it's a drilling phase though. And during this phase, we are going to get to know more the rocks and get to know their petrophysical properties. So we are going to delve in well testing, in having samples from the underground to do all what we call geomechanical studies on them, and so on and so forth. So laboratory testing, yeah. So during this phase, we are actually acquiring a lot of data that we will use in the next phase, which is development. So there is what we call development drilling. So this is part is mainly made in order to drill more wells and to get to produce. Okay, so this is why we call it development. We are going to develop the area or the field. Yeah. After this, there is production, and during production, we are actually we will have to pump from the well the oil or the gas right to the surface and to get to produce it. And it's a whole story, but it's not the topic of today. And during this the same phase, we will have also what we call EOR stimulation in order to enhance the productivity of the reservoir. So it's not yet also the topic of the day, but in case. After this, we have a plug and abandonment. So everything dies, even an oil well. So after we got to produce from it, and the reservoir has not that power or that pressure to produce, we are going to plug it and abandon it. Yeah. So as you see here in drilling, drilling is actually here in the three first phases of the well life cycle. So a drill engineer, a drill supervisor, drill crew are actually intervening in all the three first phases of the well life cycle. Okay, so to summarize, drilling is mainly construct a well, and we construct this well in order to explore, assess, as we told in the appraisal phase, or develop a field to produce oil and gas. As simple as it is. So as you see here, there is this is the well. It's mainly drilled like this. So we are actually beginning with a big diameter, and we are ending up with a small diameter. And yeah, this is the reservoir, and actually we are, this is a vertical way, by the way. And we are actually aiming to produce from this zone. So we will have to perforate the casing and to convoy what is here in the pay zone to the well. Yeah. So as you see, as you can know, drain operations are all over the world. So we can drill in the desert, in the Arctic zones, on jungles, everywhere there is oil, and we have a probability to find oil or gas. So as you see here, there are some pictures of drilling, of onshore drilling, because there is also offshore, which is made in the sea. So as you see here, there is what we call, as I told you, offshore. In offshore, the story is quite difficult, is quite different also. We are actually not intervening onshore, so we are dealing with water first. So as you see here, there is what we call the mine riser here, separating from the drain barge, jack up, or a semi-submersible drain ship, anything from the water level. So this part is what we call the marine riser. And actually, what is done in offshore is either we have this four choices. So we have either to use drain barge, jackups, semi-submersible, or drill ships. So it all depends with these depths, the depth of the water. So if we have small depths or we have what we call shallow waters, we are going to use a drain barge. And if we have operation at water depth up to 500 feet, so we are going to use jackups, which are really usable these days. We have also semi-submersible and drain ship. So it all depends of the water level, separating the sea level and the starting here. Okay. So this is how it works during offshore. Now let's talk about drilling equipment. So in order to make that hole, we are using a lot of equipment. And actually, the principle is the same everywhere, but the technology is not the same. So we may use the ancient drilling or the old drilling, mainly using Kelly joints and rotary table, or today's version, which is using the top drive. The system is the same, but using the Kelly joints, it will require a lot of time. And actually, top drive is here to help us to make fast assembling of the drain pipes. So yeah, actually, the top drive is a technology replacing the Kelly joints and the rotary table. So I split the equipment into types. So we have the equipment we are using downhole, and there are the equipment we are using in the surface. Okay. So let me check the chat first. Drilling is part of oil and gas production. No, it's not a part of it. Actually, production, as I told you, as I explained it, comes after the drilling. So we are producing right after we made the hole. We constructed. Actually, we drill it. Yes. So reach the production reservoir exactly from where? Yeah. Exactly. That's it. So let's get back to the slide. So what we have here, as I told you, there is what we call downhole equipment. So it's mainly all the equipment we are using downhole, and there are drill bits, drill collars, heavyweight drill pipes, pop joints, drain jars, downhole motors, fishing tools, casing, etc. So actually, the drill bit is the first equipment that is here to drill, and it's got into contact with the rock. I will show you in the next slide some pictures of it. And we have drill collars, which are actually heavy drill pipes, actually used mainly to provide a weight to to the the drill string. Sorry, I need to accept this guy. Yeah. And we have heavyweight drill pipes that are here in order to make a transition between the heavy collars and the drill pipes. So it's less heavy than the drill collars, and it's more heavy than the drill pipes. So they are here mainly to make this transition. There is what we call pop joints that are really pop joints are the small drill pipes. Actually, mainly use it for the need. It's not so actually a drill pipe nowadays can have about 30 feet, and the pop joint is less than that. So it depends. Then jars actually mainly use it during stack. So actually there are jars, and we have hydraulic jars and mechanical jars, but these tools are mainly implemented to like provide some chokes to the stack pipe zone. Yeah. We have also downhole motor. This motor are tu nous entends pas. Just tu sais ce que tu dois faire, just activate the audio. Active le audio qui يدخل للزوم. راح تسمعني. Yeah. So I thought, sorry, I just replied to this guy. We have downhole motors. Actually, these motors are here mainly to we can have MWD or LWD motors, but they are here in order to steer the bottom hole assembly and provide us with deviation. Actually, we are implementing downhole motors in order to drill our horizontal wells mainly. And we have LWT tools, which are here to gather some logs. So it's logging while drilling. So it's a downhole motor actually used for that. We have also fishing tools. We have overshots, baskets, and so on and so forth. It's another topic. Actually, I cannot really explain you the fishing tools, but actually it's here for to be used in case we got a fish downhole. So a fishing crew will come to the location and like run downhole these tools in order to fish the fish. Yes, and we have the casings. Actually, the casing are here to protect the well while we construct it. Yeah. As I told you, there is also surface equipment. So we have a rotary table, Kelly joints, top drive. We are going to see them in the next slide. BOP, med pumps, med tanks, decasers, desilters, descenders, sweepers, crown blocks, and the mobile crown also. And we have, of course, engines in order to run all of this equipment. So there are diesel engines. We use in the location. to provide power to run all of this equipment. Okay? So, so this is how it works. Actually, I put two pictures of the old drilling and the today's drilling. So we have the old drilling mainly, as you see here. We have the rotary table here, and we have the Kelly joint here. So actually, the Kelly is a joint that we are using in order to steer every single pipe downhole. So we are actually making an assembly between the Kelly and the drill pipe in order to steer it downward, and it's a time-consuming part. So this is why we actually invented what we call the top drive, as you see here. So this is actually the top drive. It's a motor that comes right after the swivel, and it's here to run and to steer the drill pipe without the need to use the Kelly. Here it's a manual work, and here it's an automated work. So the story is a bit different, and yeah, this is why we invented this top drive. So yeah, so we have the engines, we have the blowout preventer. I think that I didn't mention. See, I mentioned it. So actually, it's a device that is here between the well. So it starts in the cellar up to the drain floor. So it's a series of how can I say it? It's a series of let's name them valves, not that much, but BOP is here to how can I say, to close on the well if we got an eruption or a blowout. So it's an ambulation. So BOP is a tool, is a very critical one in order to ensure what we call well control. Okay? And you see here, there is the drilling tool or the drilling bit, drill collars, heavyweight drill pipes, and drill pipes. As I mentioned, this is the casing that we are actually, once we drill, we are going to, it's actually, it's happening with phases. So mainly we start with 85.8 diameter. I'm talking in inches. So we are going to drill that phase, and we are going to secure it right after this by running hole casings. Okay, and after this we are going to use a smaller diameter in order to construct, as I said, this type of wells, as you see. So we have surface casings, we have intermediate casings, we have also intermediates and production casings. We have also liners. It's not here, but actually this is the schematic of a well. Mainly, we have there's let's name them five phases, counting the conductor pipe. Okay. So yeah, let's get back to this slide. I think that I am done with it. And please, guys, write down all your questions in the chat box so I can answer them right after my presentation, okay? If you have any questions, of course. So now let's jump on what we call drill engineering. So there is a whole subset of petroleum engineering that is here in order to make sure that we design, we implement the right safety procedures in order to drill that way. So it's not always a manual work. There is a whole engineering activity behind. Okay, so I am a drill engineer, and I was supposed to do this right after my graduation, but I worked on something else, so I started my career on hydraulic fracturing, but it's okay. So drill engineers are mainly here to design and implement safety and safety procedures, and also design what we call drain program. So this is what we call a drain program. So actually it summarizes all the formation we are going to have, and the end of phases, and all the casing diameter. It summarizes everything, all the parameters needed in order to construct this well. It summarizes also all what we call MED parameters and MED properties, including yield points, MED weights, and so on and so forth. Here they are using first the air drilling, so which is actually a type of drilling. To be honest, from my side, I didn't see this air drilling, but it exists. So actually, we are pumping air or gas in the well in order to actually we use this air drill mainly for the first phases. Okay, right after this they are using this is the formation pressure. So they are using drill fluid, so they are using med with its density. So as you see here, 1.4 to 1.6, and yeah. So we are going to actually construct this well, this manner, using med, and the design of it is all about what we call a med window. So we have what we call a collapse pressure, and we have a burst pressure. And also this is for casings, and we have also the pore pressure and the formation pressure. We have to make sure that our ECD, or what we call equivalent circulating density, is in between these two, pore pressure and formation pressure. Okay, so actually this is the first task of a drill engineer, is to make sure to elaborate this kind of program, to be followed, of course, by the drilling crew on site and the drilling supervisors. Yeah, so actually also drilling engineer is here to help many servicing companies in providing what we call directional drain plans. So as I mentioned, not all the wells are vertical. We have also horizontal wells, and in order to build this horizontal wells, we have to use, I told you, med motors and all the stuff of directional drilling, and the drilling engineer is here to help on this. So he will actually tell the servicing company if the directional drill plan is okay with the initial program, and so on and so forth. What we have to mention is mainly drill engineers are mainly working for servicing companies and also for operators. So they are here in order, as I told you, to elaborate a program to be followed. So in the drill program also there is what we call the drill fluid program. So there is a whole activity or whole servicing activity which is centered on the drain fluid. So there is an engineer that will be in charge of following the drain parameters on site. And the drain engineer is here to tell him if the drain parameters are okay with what is needed or not. And yeah, there is also the cementing program, which is super crucial in order to ensure the well integrity. And there is a whole servicing behind also, but the drill engineer need to make sure that the cementing program provided by the servicing company is good, and is as we need, in order to add it to the drain program, the initial drain program. So as you see here, this is the casing, and this is the cement. So what we do is actually we pump downhole cement that will fill out the annular space between the casing and the formation. So we need to cement our casing in order to ensure our well integrity. We do not run in hole casings without cementing them. So this is actually cementing is a whole engineering activity though. So there is whole parameters around. It's not our topic of today, but in case. Yeah, and we have also drain bits. So this is the drain bits, as you see here. What comes here at the first part of the, as you see here, this is the drain bit. It's the main tool that comes into contact with the formation. So we have a lot of types, including PTCs, tricon, and so on and so forth. It's not our topic of the day, but in the drain side, there is what we call a bitman or a bitwoman. This is who is in charge of actually flowing the drilling performance of the drill bit. So what we have also to mention that these bits are being provided by servicing companies. So they are here in order to follow up with ROP optimization and so on and so forth. It's another topic, but actually there is a whole studies on the drill bits and how we choose them and how we implement them during the drill operations. Okay, so the drill engineer is here to validate all of this parameters, all of this things before getting to drill the well. So the drill program need to be well prepared and ready right before beginning with the drill operations. Okay, so there is also what we call casing design, which is super important. As I told you, the casing is here to protect our well, and we need to actually implement the right one and use the right one downhole. So it comes with a lot of varieties and a lot of types. The casings are super various. But the engineer is here to make sure that we are using the right casings in order to ensure, as I told you, the well integrity. So there is a whole study, and it's all it begins with what we call the mid window. So there is what we call the formation pressure or the pore pressure, actually here in green, and there is what we call the fracture gradient, actually here in red, and there is what we call the ECD. So I told you that ECD is the equivalent circulating density. What is the equivalent circulating density? It's not an exact science, but it's the density we are having, the drill med are having downward during circulation or in dynamic conditions, right? So we need to make sure that this ECD is between these two. That's the pore pressure and the fracture pressure. Okay, and the casing, in order to elaborate this casing design right after the drain operation. So the ECD, I told you that should be in between these two. When we are ending up with the drain, we are going to case the well. So we are going to run these casings. And there is a whole study of collapse pressure and burst pressure. So we need to make sure that the casing we are running downhole won't be collapsing after we are going to cement it, and won't be bursting after we are going to pump either cement, slurry, or something else downhole. So it's a whole study. It's something that is really made for purpose, and the drill engineer is actually here to make sure that we are going to use the right casings. I hope that you actually understood this, but in case you didn't, we will come after I finish my presentation. Okay. Actually, this is some additional tasks of a drill engineer. Drill engineer plus what we mentioned. I mean the elaboration of the drill program. There is this. So actually, drill engineer can be a drill supervisor. By the way, he can uh, go to the well site and assist the drill supervisor. And also, the drill engineer is here to um, conduct some cost evaluation and analysis, which is super important because there is what we call NPT, non-productive time. And a good drill engineer is here to tell us if we have this much of NPT, how we are going to spend money for it. And it's super crucial. This is why drill operations are a bit difficult because they are related directly to money. So time in drill is money. So it's super important to conduct the operation in the time lapse actually mentioned in the drill program. So we have to pursue it. And also, the drill engineer is here to negotiate contracts with suppliers, vendors, and service providers. So I mean, the drill engineers working for operators are here to negotiate engineering and sales whiles the, this things of vendors and suppliers. We have to buy the right material in order to construct our well, so the drill engineer can assist. Yes. So let's jump to the last part of our presentation, which is drill technologies. I tried to enumerate some of them because, as I mentioned earlier, that the drilling is something that is evolving. It's something that is quickly evolving, and every day we are having new technology implemented on drilling. So I tried just to enumerate some of them. First, let's talk about the underbalance drilling. So as I told you before, so actually to drill a well, I told you that we are pumping mud downhole, okay? So there is what we call the overbalance conditions, and there is what we call the underbalanced condition. I will show you right after this slide a diagram to understand why are we implementing underbalanced drilling. But mainly if we go with overbalance, we are going to actually create some damage near the wellbore, and it's not good, especially when we are close to the reservoir. So the underbalance drilling is actually mainly used when we are close to the reservoir. And as you see here, we are going to control from the surface the influx. We are actually going to have an underbalance condition, and which means that we are going to have the pressure in the well below the pressure of the formation. I know it can seem to be dangerous, and it can create blowouts and all the stuff, but don't worry, we all have to implement this underbalanced drilling. We have a set of surface equipment in order to avoid this. It's not today's topic, but I really wanted to mention this technology of drilling, which is underbalanced drilling. We have also coil tubing drilling. Actually, you see all the equipment I already mentioned, the surface and the downhole equipment. This equipment can be minimized and can't be like not used to drill well, or mainly to have the coil tubing drilling. So it's a good alternative for the conventional drilling, but it's still that it's not usable for all drillings, all wells. We have to mention this. So actually, I don't know if you are familiar with coil tubing, but coil tubing is mainly uh, is an intervention. So we are running, as you see here, a coil, and we are running downhole. Either we pump nitrogen, mud, water. It depends on the intervention, but we have a whole system to pump and to slide in the well, but we don't have a system to rotate. I don't know if I mentioned it earlier during this presentation, but in order to create a hole, we need 3 functionalities. So we need to pump the mud or the water or whatever. We need to um, pump to rotate. So actually, mainly this rotation is provided by the rotary table or the top drive, as I mentioned, and we need some weight in order to slide, in order to advance on the drill, in order to create the trajectory or the pathway. Okay, and in the coil tubing, we are just having the pumping and the sliding part. So we are not really able to rotate, which is not that good, because we are not going to have how can I say it? A slight trajectory. We are going to have a tortuous one, which is not that good, because I told you before, right after the drain, we are going to case the well, and if we have a tortuous path, it's really a nightmare for the servicing company taking care of the casing. So we can have a stuck casing, and it's something that I am not wishing to to anyone. So yeah, so this is mainly the disadvantage of the coil tubing drilling, but it has its benefits. So as I told you, we are going to implement less equipment. So we are going to reduce the footprint. And also we are going to have less personnel on the site, so less danger for them and so on. Okay? We have also managed pressure drilling. So actually, it's another story, but it's here in order to manage the pressure downhole while drilling. So actually, this is the surface set of equipment of managed pressure drilling operation, and what we are going to make here is, like as I told you, we are going to manage pressure downhole, especially when it is when we are having a tight med window. So this is the med window. It's the depth slash the pressure. So as I told you, there is the fracture pressure, the pore pressure, and the collapse pressure. If the collapse pressure is actually, the collapse pressure is obvious, will be less than the fracturing pressure. But what I mean is when the collapse pressure is near to the fracturing pressure, and we cannot really change the drain med weight during the phase. What we are going to do is, actually, we are going to call a servicing company for managed pressure drilling. It's happening in seconds. Like, we are changing the pressure downhole within seconds, and it's a good alternative to avoid all the lost circulation problems, the stuck pipes, and all the problem related to drilling mainly. Okay, and also we have digital drilling, which is something I am truly impressive about it, and I am truly passionate about it. So as I told you, drilling is evolving, and there is what we call the drilling 4.0. So the come of the artificial intelligence in all the industries, including ours, petroleum engineering, is having its impact. So there is what we call digital twin. So as you see here, we can actually have a digital twin to the real drain operations, and by optimizing what is being implemented in the digital twin, we are going to optimize what is happening in the reality in the on-site. Okay, so the drain engineers can have their decision to make on this digital twin before having the real how can I say, the real operation. Okay, we have also remote monitoring and data centers. So there is what we call RTUM data centers. So it's mainly real-time data acquisition, which is transferred to data centers. And the drain engineers are in front of screens, as you see here, and they are tackling the drain parameters on in real time, and they are telling the field population how to optimize the drain. Okay, and it's super good, and it's super cost saving and time saving also, because the drain operators can make mistakes, but when we have this kind of technologies of real-time monitoring, we are actually helping the population on site to make decisions. Okay, we have also artificial intelligence. So mainly it's for implementing algorithms and discovering patterns on actually this topic of drain optimization. So for my part of example, for example, what I did during my master thesis is I implemented or I discovered a pattern in order to tell the driller if we are going to get stuck using this set of drain parameters or not. So it's a good it was a good work, not that because I did it, but actually it will be a cost saving and actually time saving for both parties, I mean operators and contractors. Because if we got stuck during drilling, it's a nightmare, believe me. And we can go to fishing, we can have a lot of problem after getting stuck. So better to not get stuck. Stuck pipe is when our drill string is stuck, so we cannot move it, we cannot rotate it, and it will be really difficult for us to remove it from the well. And yeah, it's actually a good issue of our industry. We have also IoT, which is Internet of Things. I don't know if you guys are familiar with this, but actually it's here to implement in devices. During drain, we acquire a lot of data, including med logging and drain logging. So we have drain parameters and med parameters. If we can implement this IoT's devices on each single sensor we are having during the operation, and get it transferred to center in which we are going to mix it with some artificial intelligence and get to optimize it on real time, actually we are going to save the game. And in Algeria, we are not that centered to the digital drain, but actually worldwide, it's something that is taking a good move, especially when we have NOVs, drilling rigs. NOV is actually a company that is well equipped with this technologies. Okay, and we have automated drilling. So I don't know if you know neighbors drilling. So actually an automated drilling, like automated pilot, like we do not have to intervene, or the human to intervene. We do not need a driller, so we put it on an automated, and it will make its decision alone. It's something that is really interesting, but it's not recommended in especially for exploratory drilling. Okay. So I hope that you enjoyed my session. It's 8 sharp, and I made it in 1 hour. So keep in touch, guys. These are my contacts, so you can find me on LinkedIn, Instagram, and this is also my email for professional contact. And also, OPA is so kind. They are announcing a discount for its courses online. So let me just write down the code if you guys are interested to purchase uh, a course on their website. So well, let me just write it down on the chat. So this is the the code of the you can actually use for wait, you can actually use for your next purchasing on OPA in order to get minus 85% of discount on their courses. So I hope that you enjoyed my session, and if you have any other questions, please feel free. So let me check the chat box. Okay, let me scroll up. Can you please explain really means in drill? Okay. So as I told you, in directional drilling, we are going actually to create what we call a horizontal well. Okay. And in order to do this, there are a lot of parameters that we have to take care of, including the inclination, the azimuth, DLSs, and also the vibration parameters, stick and slip, and so on and so forth. It's another topic, but I will explain the inclination. The inclination and the azimuth. Inclination is the angle which is made between the well trajectory and the horizon, the vertical well. Okay. And the azimuth is the angle made between the well trajectory and the north. Okay, it's something that is that is really it needs a session for that, but I hope you understood what I mean. Okay, what does it mean by all-round drilling? What's that? ARD. I don't know it, to be honest. How the casing selection is made. Okay, so the selection of the casing is actually made on, as I told you, on the burst and the collapse. Okay, so every single piece of casing can collapse or burst. A collapse is like being interfered from outside, and burst is like exploding. Okay, so if we put a lot of pressure right and inside the casing, it can burst, and if we have a lot of pressure outside of the casing, it can collapse. It's a whole process of calculation. But let's get back to the mid window so I can explain it. You see here, there is this is the intermediate casing of 1362.5. Firdaus, are you here? So you can understand my explanation. Please raise your hand if you are here, or unmute yourself so you can. Wait, let me check the participant. Yeah, she is here, I think. Okay, or he is here. I don't know, to be honest. So actually, the reservoir engineer will decide on the first or the diameter of the liner or the production casing we are going to use. Okay, and it's the first diameter we are going to have. Actually, this is the casing, for example, of the production. Okay, so we are going to have this casing. So the reservoir engineer will make all his flow assurance stuff, the drainage, and will study all of this, and will tell us as drill engineers. Actually, making a drill program is a good teamwork project, you see. So the reservoir engineer, the geologist are all here to help. Once we got this first data, which is the diameter of the liner or the production casing, we are going to decide of the casings above it. Okay, we are going to select diameters. In order to do this, we have to confess between the met properties or the pressures in the wellbore and the casings, the nuances or the types of the casings. We have the drill handbook. So it exists on the website, on the web, on the internet. You can search for it and you will find it easily. And we will make collapse studies, burst studies, and traction studies. And based on these three things, we are going to decide on the diameter of the casing we are going to implement above the production casing or the liner. Okay, I hope that I answered your question, but mainly this is how it works, the casing design or the casing selection. Okay. There is what we call well construction engineer. It is the same as drill engineer. Yeah. Actually, in SLB or Schlumberger, there is a business line named well construction. So when we tell well construction, we mean by that drilling and all the servicing around. I mean, drill bits, drill fluids, cement, and all the stuff. Okay, directional drilling. So yeah, this is how we can name it well construction if it's okay for you. What does it mean to land a casing in incompetent shale? Uh, Actually, it's another topic. Land casing. So actually, shales, gas shales or oil shales, it depends. There is a difference between the sandstones and the shales, and shales are having um, some critical parameters to take into consideration. So it's mainly oriented to geomechanics, elasticity of the rock, and all the stuff. I won't dive into it for today, but maybe in the next sessions. But land casing competent shale. I don't know what you mean by it competent shale, but the casing operation in a shale is a bit different from the casing in the sandstone, because I told you shales are quite different from sandstones and the other. Actually, the difference between sandstones or rocks in general and shales, it's their permeability. Okay, so shales are having really small permeability, and they have also a problem of elasticity. Okay, we need to take this into consideration, but it's mainly being done by implementing geomechanical models and all the stuff, and it's quite different, as I told you. But please, I don't know what you mean, but by competent shale, I don't understand this term. What can you do in case of stuck and in case of kick? Actually, Oh, good question. When we have a stuck pipe, there are a set or process of remedial action, and stuck pipes are being different. So there is what we call differential stuck, and there is what we call mechanical stuck pipe. And the remedial action of these two is are quite different. First of all, maybe it depends on the situation, you see, because the driller and the drill supervisor is here. Because by knowing the nature of the drill of the rock we are drilling and the nature of the formation we are drilling, we can actually elaborate a remedial plan for it. But a stack pipe, especially a differential stack, is something that we have to tackle very quickly. If time passes, it can be worse. So we can actually implement jars, hydraulic or mechanical jars, it depends, in order to make some percussions on the well. And maybe we can free the drain pipe. If no, we can also inject acid in order to dissolve the mud around I am talking about the differential stack, okay? Or dissolve the cake or the zone of contact between the drain pipe, the drain string, and the formation. And after this, we can try to fish. So we are going to first calculate the neutral point. Actually, it's something. The remedial actions of stuck pipes are quite it's another topic. Okay, I cannot elaborate that much on this, but mainly we will try to do our best. In case of a kick, actually what we are going to do is implementing well-controlled methods. So we have driller method, the weight and weight method. It depends, but mainly this is what we do, drilling a kick, because the kick can quickly like turn to a blowout. So a kick is the eruption we are having and in the wellbore. Okay, when we see pressure increasing in the wellbore, but we do not have any blowout yet to the surface. Okay, so there is a whole well-controlled method. It's not today's topic. I cannot elaborate that much on it, but this is what we do in case we have a stuck pipe or a kick. Okay. Do we have digital drilling technologies in Algeria? So we had RTUM data centers. So we worked on remote control. Actually, there are two companies. I won't be telling their names in Algeria, but this business is done in Algeria for the moment. I hope it will come back. Yeah. Thank you for your amazing present. Most welcome. Thank you for attending me today. Thank you, dear. There were on paper meetings where the engineer mentioned that the casing will be landed on competent shale. I believe the formation will be more of shale than sandstone. To be honest, it's not how we work in Algeria. So in Algeria, we are in order to decide the landing point of the casing, you mean? It's mainly you see this. You can see the mid window on the screen, right? So it's the landing point is actually decided by doing these studies of collapse. As I told you, collapse, burst, and traction. We are going to end up with an optimum TVD or TD. like the depth in which we are going to land the casing. We have also LOT, so leak of tests and FITs, formation integrity test, but these tests are not really being implemented every drilling, okay? So based on the casing design slash the med window, we are going to decide on the landing point of the drill and where to put the casing shoe exactly. I don't know in which country they are working like this, but I'd love to hear more from you. Success, Khahimi. Oh, sorry, I couldn't spell your name correctly. Of course, the landing point should be the hardest, but it can be sandstone. It's not really related to shell or sandstone. It should be the hardest. And by implementing this med window, as I told you, study, we are going to know where is the hardest point in order to set the drain shoe, the casing shoe. Nigeria, yeah, I can understand. We are not working that way in Algeria. This is what I know for my part. I hope that I answered your question. Yeah, so I think that we should wrap up. We are already done with the time. If you have any other questions, guys, please uh, address them in the comment. I will send you the um, OPA code in order you send to the chat. In order you guys to I don't know why it's going to the waiting room participant. Sorry, I have to fix this. Most welcome, Brahim. Thank you for attending today. Guys, I am trying to send you a code of a discount on OPA website. So I don't know why it's not working. I cannot send it to the sorry. Maybe I can write it down. Oh, sorry. I will have to write it down on a Google or on the slide directly. Are you able to see my screen, guys? Hello? If someone can unmute yourself, I am feeling alone in this presentation.
Yes, you can.
Yeah,
I see your screen.
yeah, okay, nice. So this is the OPA code. You guys can use it in order to have some discounts on the platform. So it's OPA Nina 2024. So you can use it in order to have minus 85% of discount on the courses already available on OPA website. I will be actually also sharing this on LinkedIn maybe and on my Instagram. So you can follow me on Instagram and LinkedIn though. I will be making a post. And thank you guys for joining me today. I really enjoyed this session, and I hope that it was informative and you enjoyed it. Thank you guys. Thank you for having me. And yeah, keep in touch and stay safe. Okay, guys. See you.